My name is Svetlana, and I'm a tech manager at Globant. I'm working with cross teams and help on many QA automation projects. Technology is a big passion for me. Nowadays, I'm driving into machine learning frameworks and Internet of Things platforms. And today, I would like to talk with you about testing automation with AI. Well, when you hear news about artificial intelligence, it might be easy to assume it has nothing to do with you. You might imagine that artificial intelligence is only something the big tech giants are focused on, and the AI doesn't impact your everyday life. In reality, artificial intelligence is encountered by most people from morning until night. For example, when you open your phone with Face ID, looking for social media, Google search, using digital voice assistants, and many more. How AI used in testing software. Companies large and small are looking for ways to reduce cost and improve the scope of reliability of testing. And it is under the pressure that testers are more often turning to artificial intelligence and machine learning to augment their testing processes. How can AI enhance the software testing process? This presentation will cover some of the main benefits of adding AI to the software testing process and why you should consider adding it to yours if you haven't already. Okay, how help teams to test faster? Today, I will demonstrate a concept how to do it. We will take a big data approach and we will use machine learning to speed up the testing. We will say goodbye to test scripts, which take a lot of efforts to create and ever longer to maintain. We will create a test using architect of natural language. Using AI for testing software is an emerging field in software engineering. So how to do it effectively? In this presentation, I will describe how convolution neural networks and deep reinforcement learning can be used for this new initiative. We will execute exercises where we will use the pre-trained CNN model, image detection API, and we will build a model from scratch. In my opinion, the exercise developed can be applied by anyone with good experience in the software industry. Also, you need some knowledge. They are not very difficult to achieve. Almost of them can be covered with online courses available on different platforms. Specifically, intermediate knowledge of Python is required, and advanced data design, modeling, and basic neural networks understanding are required too. But first, let's list the software testing challenges. Today, automated testing is based on DOM structure. As a result, traditional test scripts are breaking any times as UI changes. This is because of scripts cannot find an element single locator like ID or XPath. As a result, rework is needed after every dev cycle. And also, it's a big effort to cover a huge number of layers need to be tested. So let's consider what the functional testing is. So the functional testing, this is a set of scenarios, and every scenario is a set of pages. A single page is a set of elements. We need to perform some action with these elements. So in our platform, we will create two phases. The first phase, the phase which will detect our elements within the page. And the second model will be perform action with these elements. For the first model, we will create detection model training with convolution neural network. And for the second, we will use deep learning model with neural language processing. Let's start our exercise. The first, we will create the first model, detection model training with convolution neural network. To start build this model, you must have installed the following dependencies on your machine. Of course, it should be Python. You need to install TensorFlow. TensorFlow is a free open source software library for machine learning and artificial intelligence. This is really, really a powerful library, and it's really popular for our days. And we will install some more dependencies like image AI library. This is some additional library we will use just to simplify our code. So you will see our code will be presented in a few lines, and it will be really, really easy. So, and also we will use some Python libraries like Pillow and Python-Seract, which help us to detect elements. So we'll show how we will perform it. So on this slide, you will see flow, how we will build our model. This is a common flow, can be used for any machine learning models. It will be the same flow for convolution neural network, for neural language network, and so on. So the first step, it will be we need to create a data set. The next, we will train this data set. The next, we will create model, and this model we can use for our data analysis. So we can perform some prediction. We can receive information using our model. So let's start to build our model. We'll start with the first step, preparing our custom data set. So for this step, we need to prepare images which we want to use to train for our model. So in our case, it will be a data set of images of web pages with web elements on these images. So this is a really complicated part. It's a question how to create this collection. And this collection, it should be collection about 500 images. This is a minimum recommendation, and of course it's really complicated to create your custom data set. I will try to, I will share with my experience, and of course you can use this experience yourself. Let me show. So how I created my own data set. I just use it images Google search results. So this is these results provide me with a huge amount of elements with some pages and with web elements presented on these pages. And I just need to save, capture, navigate to a separated page, capture this page and in my collection folder, and so on. I can perform it really quickly using just some additional tool. We can use developer tools in our browser. Just put here JavaScript command, and with this command, we can create a list of URLs which provide us the search result page. Okay, We have this list URLs, and for now we can navigate to every page and capture this page and save on our local collection. We will use I developed some really simple Python script for this purpose, which just navigate, capture, and save image on our disk. Okay, so to run such an easy script, it will take maybe 20-30 minutes, and our collection is done. So it will be 500 or 1,000 images in our collection just in 50 minutes. Okay, so the next step, just show you. We need to review our images, just to remove images which doesn't match our collection, so doesn't present a web page and our elements. So we will filter and we will review all our images, and it's done. So let's go with next step. The next step, once we have our collection of images, we need to annotate our objects in these images for every images. So we can use a really simple tool, image annotation tool. It's named Label Image. It's easy to install on any platform, macOS, Windows, and so on. And I will demonstrate how this tool works. So you open a directory when your collection is located, and this is will be a list of all your images. And now you need just start annotation. Every single image, you need annotate your object. So you will create a rect box for object, and you will put a select classificator. So for this example, I have a set of buttons elements, and and you need to perform all this for all your images in your collection. So when you're done with this part, it will be created. You saved annotation, and annotation, it will be simple for every image. It will be created XML file with annotation. With full information, full annotation information about how many objects, coordinate of these objects on the page, classificator, this is a button, and so on. So we have done with our data collection, and we can start to build our model. So this is one additional step before we start building our model. We need to split our collection in two collections. 80% of our collection we will put in train folder, and 20% we put in test folder, just to split our collection. That's it. Okay, so when we're done with data set step, we can train our data set. So we will use image API library to train our model. So we will create object, train object, which will train. We set up data directory. This is a directory when our collection, test and train collection are located. We will set up a set train configuration. The first parameter, it will be array with our object classificators. In my presentation, I just created 3 classificator for button, checkbox, and radio button. And also, this is trained from a pre-trained model parameter. It's optional parameter. You can use it when you, for example, have some model, pre-trained model, and you want to continue train this model again. It means that, for example, you stop train your models, and you can in any you can improve your model and train it again, so you don't need to perform it from scratch. And this is interesting parameter, number of experiments you would like to perform to train your model. So in my example, it's 20. So it means that it will be with our data set, it will be performed 20 experiments. And just be aware, it really consider on your machine CPU. So for example, when I trained my model and used just 20 experiments, it took me more 72 hours. So be aware, it's really a long process. And for to train a real model, it should be recommendation. It should be 100 and more experiment to train your model, and this model, it will be give you a more accurate result when you will detect your elements. So be aware this parameter, it should be more 100. I will not run now the train model method, because it's time considered, and I will just show you. I will start and create my object for my model. So, and when we start train this model, in models folder for every experiment, if, for example, I run 20 experiment, it will be created 20 models in models folder. So this is some information, statistic information about every model. And the next step, you need evaluate your models. So from 20, or it will be, for example, you will have 100 models. You need to find models which will be more accurate, and you will use for your next steps. So the evaluate model will provide you with statistic information, and this is a really good parameter, map parameter, which show how prediction is high for a specific model. So when this value is more close to 1, it means it's more accurate and prediction will be more accurate. So for all 20 evaluation result, I found my the best. Of course, because I had just 20 experiments, and my my model will show some not really good results. It can be some strange results. So I need to train my model again and again and improve my model. But let me show how it works. So this is a model which will save on your disk space. And this is, you can see, it's just 250 megabytes the size of your model, and means that this model you can use copy to any server, to any framework, and you can use in any platform. So you build your model, and you can use this model for test automation for any projects. So, and it means you have this model, and you can load this model, and you can start detect objects from image using this model. So let me show how it works. I prepared some images just downloaded before this presentation from internet, just to show how it works. So this is Netflix page, and I will try to recognize button elements within this page. So let me show how it works. This for this method, I will put my Netflix JPEG name, and this parameter it's optional, but it's really good to use. It will be generate image which with detected object. It's really useful to visualize the results of detection. So let's start this set of code. So you can see, let me show you what was detected. Yeah, so it was detected button. Yeah, it's not really accurate for this page, but the idea is that it will show us object detected within the page. Plus, you can see it will show us the number that prediction is 82% is accurate, so it's prediction with this value. And let me show you some more example. For example, Amazon page. So we have some buttons within this page. We'll see how it works and which object will be detected with for this image. Amazon. Okay, let's run. Okay, so its result return us three object, button object, and we'll see results. Yeah, so this one, it was detected. So you can see we sometimes we have with some object it's false results. This is because it's not it's still a good trained model. This is just for demonstration, and we will have some pass and fail results. So, and as the last example, I would like to show, this is Bing site, okay? Yeah, so this is sign up button. And for example, if we have on the page a multiple of button elements, we need to understand, so we need click specific, for example, sign up button, just perform action with this specific button. And we need to recognize this sign up button from all set of buttons within our page. So I will show how we will do it. Okay, we'll put here Bing. It will return detection two elements, and will show these elements detected. Yeah, so you can see this is a sign up button, and this is prediction. It was show me. 68% is prediction how accurate that it's button object. Okay, so let's see how we recognize that this is really a sign up button. You can see this is the region of this object, and we can crop this region from the full image. So we will use here image Bing, our image, and we will put here our region. Okay, and we will run here. Yeah, so you can see we just crop this box and put it in region, and we can perform the next action with this region. So we use PyTesseract library. This library which can read text from the image. So we can extract this text from the image. So let me show how it works. Okay, I run, and I will put in console. Okay, so you can see it was detected the text within this region, sign up. So this is concept how we can build our element recognition for the first page, for first stage. So we will detect all elements on our within our page, and the next stage we need to perform some predefined steps, some actions within with these elements. So for this goal, we will build the second model. The second model, let me show. We will build creation deep learning model with neural language processing. So nowadays it's really a popular machine learning natural language processing model, and it used in different areas like bot chat and so on. Maybe bot chat is more popular, so I'm sure you hear about this. So let's build our neural language processing model. So for this model, you must have installed some dependencies. We will use Spicy. It's really good library for this purpose, and we'll use some additional dependencies library will need to be to finish and build our model. So when you have these dependencies on your local machine, we will start the first step. This prepare our data set. So it's really similar, like we built a data set for our image detection model, but instead of images, we will use BDD steps. So BDD steps, this is a collection of really different BDD steps, which can be find anywhere in any storage. So for my exercise, I used GitHub repository, and I just check features in different repositories and copied these BDD steps from GitHub. And of course, I had created my collection. Will show you. So I created and saved this collection in CSV format. So you can see this is column. This is all different BDD steps from different features from different projects. Okay, so when you created your BDD step collection, and it's really similar like we performed with annotation our images, we need to classify our steps. Let me explain how I classified my steps. So, for example, I classified and put it with number. So it means the step given I navigate to Google. So this action navigate to URL, and I classified this 0. And for example, the same steps navigate to URL, but which described in different manner. Give I'm on Google.com, it's the same classificator. Let's show more. Okay, it's the same. Okay, this is given I load Google site, it will be the same action, navigate to URL. So in this manner, you need to classify and create your own classificator and classify your steps in your collection. So this, okay, and we can start. So I will import some dependency, and I will in train data object, I will read my data set collection. So this is, I will show you my data, train data. And this is maybe some information about my data set. I have 8 classificator. Here on plot, I will just display how many BDD steps for every classificator I have in my collection. So if you create with more different description for any classificator, it will be more accurate, and it will be more accurate prediction you will have using this model. So you always you can improve your model and train again and again with improving data set. Okay. So the next step, it will be the same step like we performed for image detection, object detection. We need to sleep our data collection to train and test. So the same 80 and 20%. That's it. Let's go next. The next step we need, this is step preprocessing data. For example, we have some in our BDT context. It starts with the word given, when, and then. It's this word. It's not have any. Sense to understand the context, so we don't need these words, so we can clean our collection and clean these words from our data set. Also, we will transform our text in lowercase, and this is a procedure which perform these actions. Let's run. Okay, so I applied this procedure to this BDD step, and result was returned. This is clean without given and lowercase. Okay, so let's apply this to our train and to our test data set. Okay, so for now we have cleaned our collection, and for next we will use we will perform some interesting step. Let me show. So we will apply natural language processing techniques like limitization, stemming, words. So there are a lot of techniques you can apply So you can just play with our collection just to receive more accurate results. So for this presentation, I will present, we will use limitization. Limitization, meaning of words based on a dictionary. This is extract the base word. I will demonstrate on practical how it will apply. Also some stemming technique, extract the root of the word or stop words. This is words that appear very often and don't help to understand the context of the text, and more techniques. So I will show you some technique on practice. So limitization. I created procedure and will show how it works. So you will see learn, learned, and learning. So it's all this word have the base word learn, learn, and learn. So we apply this technique for our two collections, and that's it. Our data set is ready to train. I will perform some apply some just for user visualization. I just will not use number. I will classify my classificator with text. It will be easy to understand the results. So the 0, it will be a classificator navigate to URL, and so on. So we have 8 classificator, and we can start train our model. So comparing with image detection, I will perform 100 experiments, and you can see it takes just 30 seconds to complete this, to train this model. And of course, you can save this model on your local disk, and you can use this model for in any automation test, like I demonstrated for image detection. So let's see how we can use our NLP model to detect our action. So we will load, and for example, this is it will be a BDD step. I load a Google site. So you can see it returned me the list classificator and with prediction number. So it 99% prediction that it's navigate to URL site. So for example, we will change our text. So it's the same. It will be navigate to URL action. Let me show you more. I'm on Google site. Yeah, so it's the same. Or like mock, I navigate. So it should be, I'm sorry. Yeah, 95%. This is navigate to URL action. So maybe some more, like I click save button. I just put out results with prediction highest 90%. So it will be click the element action. Okay, so when we detected our actions, we can translate our BDD step in Selenium actions. So this is idea how we can use machine learning models and build our powerful artificial intelligence automation platform. And I hope it helped you, and I'm ready for your questions. Okay, so this is one question I can find in our chat. how to apply results of trained model in real automation functional test. So it will be your test automation framework, but we will skip in this automation framework object recognition, and you will not define actions. So it means that it will be a framework, and you will provide this framework with just test scenarios described in natural language format, and your model will analyze all your steps. You will generate your automation script automatically, so without any human interruption, and it will execute all these scenarios. It will generate test results, and you will just receive a test report, and you will see which scenarios pass or failed.
Svetlana, that was so interesting. I have so many takeaways from your talk and things that I want to dig into. So thank you so much for being here and for sharing all that.